for energy is the ability to do work. Now, remember last unit we talked about the word work, like not homework, but oh, I've got to do work. And in physics, the word work means that you push something with the force and it also moved in the same direction. And the SI unit for energy was what I called a joule. And a joule has a connection with energy. Because remember, whether you're a machine or a person, you have to have energy so that way you can do work. So energy is the ability to do work. It says here that there are 7 different types of energy. Now the problem is when you're looking at the questions, there's a good chance that there are multiple types of energy that are going on at the exact same time. So it's a little confusing, like which energy is this? It says here though that energy can be what we call converted or transformed. Oh, horrible, I wrote so big. From one type to another. Transformed or converted. They mean the same thing. Now, all of those 7 types of energies, believe it or not, for an example, we can group like the CHS students into different groups. For an example, there's 7 quote-unquote types of students that are CHS. There are actually 7 different school districts, if you didn't know that. That's a lot of school districts, right? 7 school districts that come here. Now, we can group those, or we can group the students from those 7 different school districts into, let's just say boys and girls, like, right, categories. That's what we're doing with these energies over here. All energies, no matter what type you are grouped into 2 categories. It's kinetic and potential, just like you talked about in middle school. Kinetic and potential. And you already probably are familiar with the law of conservation of energy, stating that energy is never created nor destroyed, just transformed into other forms of energy. We say, and this will be a math equation we will have later on, the E before equals the E after. Conservation of energy equation. So we'll have a few equations as well for this unit. The conservation of energy means energy is saved or retained. All of the energy, it says here, before a transformation occurs must always equal all of the energy after. Mathematically, it's there. Now, it may not seem like it's there, but the amount of energy before does equal the amount of energy after. Some of it might have been transformed as a different form, and you felt like you lost it, but you didn't lose it, okay? So I'm tossing that out there. For an example, let's just say it takes $40 to fill up your gas tank. So you put $40 in your gas. So you've got a full gas tank before worth $40 of gas. Now you drove around and you already know exactly how many miles to the gallon your car takes. There's a problem because after you drove however many miles you have of gasoline, you actually didn't go that many miles, and it feels like you lost some of that gas, some of that energy. It wasn't lost, it was transformed into friction or heat or thermal. So the amount of energy you had before, that $40 of gas, was there afterwards, but some of it got used in different ways or different forms. And so that does get a little confusing or tricky sometimes. It says here the law of conservation of energy means that the total amount of energy in the whole universe remains constant. Remains constant. However much energy we have has always been what we have. So, turning the page, here are the 7 different types of energy. I'm not sure, you probably had something similar talking about this in middle school, but for an example, there is thermal energy. Then we have what we call over here electromagnetic energy, or EM. There are 7 types of EM energies: radio waves, gamma waves, infrared, visible light. That's a whole unit on its own, electromagnetic waves. Then we have sound energy, right? Kind of like, hey, don't be blasting that music so loud in your ears or those earbuds. You're going to destroy your hearing because of the energy of that sound can actually hit inside of your eardrums, and it does destroy our hearing because energy is, sound is energy. The next one over here is electrical or electricity. Is the movement of electrons, like electricity in your house or lightning. Lightning is a moving of electrons. So when you have a buildup of electrons in the cloud in the sky, those electrons are negative and negative charge. They don't want to be by each other. Eventually, too many of those negative electrons are going to build up and shoot out of the sky, and we call that electricity. Believe it or not, this electricity or lightning actually occurs not only from the clouds down, it actually occurs from the ground up to the clouds. Those are called sprites. Those are also lightning bolts or lightning strikes that can occur from the earth up to the clouds. They're called sprites. The next one over here, they have striking a match, not the fire. So sometimes you have to like read the words. And then food that you eat is chemical. I bet the number one example you used in middle school was probably photosynthesis. That's a chemical reaction that occurs. And then the next one over here is nuclear. Nuclear, they're talking about specifically smashing atoms together or ripping atoms apart. We call that nuclear fusion or fission. Okay, and then the last one over here, which is probably the most common, but we call it something, and that's not the real physics term. You probably would call this the frog leaping or the car moving kinetic energy. That's the middle school term. The high school pre-AP physics, AP physics term is called mechanical. Mechanical energy is the high school term. Okay? Now, a little bit of words when it comes to it. I know I kind of explained it up here, but over here it says the first energy they want to talk about is thermal. And thermal energy is exactly how it sounds. It's going to be heat that is most of the time due to or produced by friction. Now, the mechanical energy is the next one. A lot of us want to call it kinetic energy. The problem is that it's actually an equation that you haven't covered yet. So many people call it kinetic. If you feel like in your gut, you're like, oh, that's kinetic energy, and that's the answer you want to pick on the test or quiz, I would pick mechanical. Now, kinetic energy or mechanical energy is not only kinetic energy, which you probably called it moving energy or energy in motion when you were younger, but and potential energy added together. That's what mechanical energy is. The definition or the math equation for mechanical energy is the sum of all of the kinetic and all of the potential added together. That is an equation later on with our notes. The next one here is chemical. Chemical energy is stored in the chemical bonds of these atoms or reactions that are going to be released when you either break the bond apart or you add the bond together. And again, plants or photosynthesis is a major example. Batteries is chemical reaction that's occurring. The next one over here is electrical. Electrical energy is energy of moving electrons, like lightning, static electricity, and irregular electricity are all examples of electrical energy. The next one after that, I'm going to use the simple word, but many of us call this light energy. Well, that's just because that's what we were taught. Like, oh, we look up and we see that in the ceiling we have light, right? We turn on the light switch, and that is light energy coming down that we can actually visibly see. But light energy is going to be what we call electromagnetic waves that radiate. Okay? Well, that is a whole unit on itself, electromagnetic waves. There's actually 7 different types of electromagnetic waves. The majority of us call it light, okay, just because that's the one that we're most familiar with, okay? But this is actually radiation. And not all radiation is bad. I get some students who really think that radiation is bad. The next one here is nuclear. And nuclear energy is energy from the nuclear reactions, or I'm going to come over here and call this radiation. Wait a minute, Ms. Munson. You just said this was radiation and this is radiation. Well, this is radiation from electromagnetic waves. Okay, we call it radiation or light. This is radiation from when we have nuclear fission or fusion, or for an example, like an atomic bomb that goes off, then that actually emits radiation out of those bonds, okay? And then the next one is sound energy on the next page. I just ran out of space over here. Sound energy is energy that is produced by sound vibrations as they travel. Sound needs what we call in physics or science a medium for it to travel. The word medium means a solid, liquid, or gas. If there was no solid, liquid, or gas, kind of like in outer space, we call outer space a vacuum, then sound cannot travel. Now, the problem is when we get to practice questions. So homework number 2, which is going to be due, I think, next week on Thursday, homework number 2, is going to be like this. Now, homework number 2 is going to have questions like, for an example, a ball hits the bat. Some students are going to want to hit or type in or write kinetic energy. I personally would write mechanical energy before I write kinetic because that's the proper term. But some students might want to write heat or thermal. Ms. Munson, when that ball hits the bat, there's touching, there's friction, there is some heat produced. What I want to do is make sure I explain to you that the homework is a little confusing, as in, what does it say in our notes? Our notes say that a lot of times, often, there are multiple types of energy that are being produced at that same exact time. For an example, gasoline is chemical energy, but what about an alarm clock? I got 3 different answers on that first period today. Alarm clock. Somebody said electrical, which I agree. I'm going to put a little line. Somebody said chemical. Okay, so what if you personally have your alarm clock that uses an electrical cord and you plugged it into the wall? That would be electrical. What if you use your cell phone and it's not plugged in at the time, and it's just like your cell phone is right here, and what does your cell phone use when it's not plugged in? The battery. So that would be a chemical. You know what somebody said earlier today? It was a good, really good example. They said mechanical, Miss Munson. I go, whoa, I didn't say that, but I should have. Mechanical. As in, what if you have like a really old, like, I don't know, super old clock or watch, and you have to wind it up? I was like, what I'm trying to say is on quiz in test and semester exam, it will not be like this, an alarm clock. What the heck? That's not enough information. It will say an alarm clock that's plugged into the wall. An alarm clock that is using a battery. So it will be more specific. But on your homework, don't freak out. Just shoot me an answer and we're going to go through it. Because remember, more than one energy could be being used. Now we're going to turn the page, and I want to take a glance at this. Miss Munson, this looks easy cheesy. This is obviously not your notes. It's not. I stole this from a middle school teacher. Are you serious? Yeah, I'm serious. It's middle school notes. Now, I will tell you, when we're done with our notes today, we will be done with the middle school notes. But there is also a quiz that I have also from the teacher. Are you smarter than a sixth grader is what I call it, quiz. And so this quiz is going to look like this, cheesy and bubbly, because it's a sixth grade quiz. Please don't do bad on that. Don't do bad. Come on now, do better. Do better than those sixth graders. Shove it in their face. You made 100. I don't know. Really, I rarely do I get 100 on these sixth grade quizzes. So, all right, as a reminder, this is something that you probably learned in middle school, renewable and non-renewable energies. Okay, there are 4 types of non-renewable and there are 5 types of renewable energies. Your unit or week 13 reading has a little bit to do with some of this, and some of your homework has to do with some of this as well, okay? So, non-renewable resources. Non-renewable means that it's going to come from resources that cannot be replaced easily. Renewable can be replaced by what we call natural means, most easily available. Like, you probably can find sunlight for solar energy pretty easily, all right? Now, when it comes to renewable, non-renewable energy, some people have some really strong feelings, which I understand. I think both energies are great. I mean, there's nothing bad with renewable or being green. There's nothing bad because you use gasoline in your car and you don't have a Tesla. There's nothing wrong with them. They're both good energies, but the thing is they both have pros and cons. And I think that's the reason why some people are stronger on one versus another, because they didn't know all the pros and cons. Alrighty, so let's talk about this. Coal, oil, and natural gas. You know, the number one mistake that I get from high school students is, where does coal, oil, and natural gas come from? Oh, Ms. Munson, it comes from long time ago. Millions of years ago, there were these blah, blah, blahs that were roaming the earth, and that's what created coal, oil, and natural gas, and that's what we use. Seriously? You're going to tell me that dinosaurs? I'm putting a dinosaur on my gas tank? That's the number one misconception. So remember, you're smarter than a sixth grader. Now, coal, oil, and natural gas does not come from dinosaurs, but it does come from, or it's formed from ancient time, as in like the dinosaur time, okay? So ancient time formed from ancient swamp plants. Not the dinosaurs, but the plants the dinosaurs ate. Not the dinosaurs, but the plants that the dinosaurs like maybe walked next to, okay? That's what it came from. Definitely not dinosaurs. So do not mark that question or that answer choice. Same thing with oil. Oil was formed from ancient marine life / I'm going to call it swamp plants. Do you see a trend there? A lot of water and moisture was trapped Okay? Now, when I say marine life, I get some students who think about, remember that last, what do you call it, Jurassic Park that came out, and there's like that big old like dinosaur ocean like shark thing that jumps up from the last Jurassic Park. Okay, some of my students think that's what marine life is. No, I'm talking about kind of like SpongeBob plankton. Ah, that's what I'm talking about. I'm talking about like those planktons or those photosynthesis algae plants that are in the water. Hopefully that makes more sense now. That's what I'm talking about when I say marine life. I'm not talking about that dinosaur or this big shark whale hybrid thing that would eat you up. Okay, I'm talking about like these plants, they're like water marine photosynthesis plants. Okay, same thing for the natural gas. Again, formed from ancient, as in dinosaur time, marine life, not those big super crazy dinosaurs, / swamp plants. But never used the word dinosaur, did I? Never. Now, nuclear. Nuclear also is a non-renewable energy. Now, I will toss out there that our sun, which is the closest star to us, uses nuclear energy, and every single star in the galaxy is a star because a star creates its own energy. We're a planet. We're planet Earth. Planets do not create and produce their own energy. All of our energy, believe it or not, comes from the sun. It takes 8 minutes for the light or the sunlight that's produced from nuclear fission and fusion from the sun to hit planet Earth. Okay? Now, wait a minute. Nuclear is under non-renewable. What does that mean? That means that our sun is actually, believe it or not, about halfway through its life cycle. It's eventually going to, look at this, run out of energy, and it's going to die. Okay? So nuclear is a non-renewable because it will run out, and it's not a thing that you can easily replace. This is going to be energy from splitting, and I'm going to put a line here, smashing atoms. Nuclear fission / fusion. That's a whole nother unit later on. I think it's like the last unit next semester. Now, the renewable energies. There are 5 types of renewable energies. And again, nothing is really bad with them, but they also have cons, okay, as well as pros. Wind energy. The wind blows / turns the turbines. Do you know what the turbine is? That's those little things, like those propeller things are the turbines. Comma. And energy is then stored in batteries. Way down here on the ground, inside this little thing, pipe thing, are batteries down there. So when this turbine spins, because the wind causes it to move and rotate, there's these big giant batteries that are down there in the ground that collects the energy. The problem is these batteries can only collect so much energy. So if you've ever seen a wind farm ever going, or kind of like when you drive towards Oklahoma, or maybe in West Texas, Kansas area, there's a lot of places that use this. Some of them are not even on. Miss Munson, why are they not turning? It might be, number one, they're broken. Number two, it could be because the battery is full. It can't accept or absorb any more energy, and so they have to turn that sucker off. So that kind of sucks. Hydropower. Hydropower is moving water in a dam that spins / turns turbines. the turbines are under the water. And the cool thing here is they have the same problem, but they can dam it up and make the dam have less water going through, or they can allow the water and more water to rush through if they want to produce more energy or have the water rush through a little bit more faster. And that way they can create more energy, okay? Again, though, they're collecting it, and sometimes it's batteries, or they transfer that energy straight to some type of power plant. Solar. Well, this is like one of the newer energies out there. And this is going to be what we call electromagnetic waves. Remember, like on the previous page, that light energy is collected, and solar cells. Again, we have these batteries, and we can only, absorb so much energy. And then the problem with this is, what do we do with those batteries? Because you know that like your AA and AAA batteries at home, you don't supposed to throw them in the trash. Why not? Because they got chemicals in them, right? You don't want to just toss those chemicals into the ground and then it's going to seep into your water and then, you're going to turn green one day. We don't need that. So the problem here, one major problem, is they have these big batteries, and whenever the battery's no good anymore, what do you do with them? They have storages and storages of these batteries, and we're like, we don't know what to do now. Like we have all these batteries that are dead batteries, right? And what do we do with them? Geothermal. Geothermal is going to be heat from inside the earth. And then biomass is going to be organic plant material like wheat and corn. That's burned. Now the great thing, there's pros and cons for these things. And on the next page, that's what it does. It's going to go over pros and cons over renewable and non-renewable energies. Okay? So the next page goes over the non-renewable energies. It says the good, the bad, and the ugly. Okay? Now, I'm going to be truthful. On the next page, one of the bad things about it is that we are going to run out. But I'm not going to lie, I'm kind of selfish. We are not going to run out of these things while I'm living, while your kids are living, while your kids' are living, and probably while your kids' are living. So we have enough oil, natural gas, and coal to last for quite some time. But they are right. We are going to run out. So that's a bad thing. An ugly thing is that they produce a lot of carbon dioxide, which causes an increase in our greenhouse gas and changes our weather and our temperatures and things like that. So that is an ugly thing, the pollution that comes out of this stuff, okay? I'm going to post this on D2L, okay, because it's just some writing, and then you can read it, but I just gave you the summary verbally. The next side is also the good, the bad, the ugly, or the advantages and disadvantages. And remember, I kind of just told you some of these disadvantages of renewable energies. A disadvantage is you have these batteries that store the energy, but what do you do when the batteries are dead? Have you ever had like a laptop or your cell phone where the battery's like, you can charge it, but it just cannot hold a charge anymore? That's what I'm talking about over here. So now what do you do with those batteries that can't hold the charge no more? That's a disadvantage. Another disadvantage is that we don't always have wind and sunny days, right? And so it can be a hit and miss if you're going to get these. An advantage is that they produce less CO2, carbon dioxide, or they produce less of this pollution, which is a good thing when it comes to renewable energy. The next page we're going to work on. So the next page here says that alternative energy resources rely on natural processes and can be used to produce energy. For a resource to be considered green, it must be renewable and what we consider clean. Okay? So let's go ahead and give those definitions of the word clean and renewable. That way we're all on the same page and you are definitely smarter than a sixth grader. Okay? Clean. The word clean means it's going to produce less pollution. And do you see the word doesn't say no pollution, less pollution, or less to zero, because some of them do produce zero carbon emissions, or what we call CO2. Now, the problem here, though, is that, oh, well, Ms. Munson, these renewable resources, like when the wind blows, it produces the turbine to turn. But when wind is blowing, there's no CO2 that's produced. So it's zero. I agree with you. Zero CO2 is produced when the wind is blowing in the air. But you know what? How did they make that wind turbine? Don't you probably see it on 45 with those big 18-wheelers, or sometimes over here on, what's that, Highway 3, like over in Hitchcock area, when the trains are going and the train tracks are like stopped and there's those big old turbines that are trying to travel? Okay, so to get the turbines or those big parts, they ship them from wherever. They bring them to Galveston. They take them off of the boats. They put them onto 18-wheelers or trains. But wait a minute, 18-wheelers and trains, what did they use? Coal, diesel, gasoline. So even though some of these renewable energies themselves can produce zero CO2 or carbon dioxide pollution, that doesn't mean that actually using this means zero. Because to make it, maintain it, and keep it rolling, or to travel it, is actually using non-renewable energies. So there is still some CO2 production that is produced. Maybe not from this, but from the byproduct of making it. Now, the word renewable means to be replaced by natural means and continually available. Now, I ain't gonna lie, we don't always get sunny days for the sun. Sometimes we're gonna have like a couple of days of cloudiness, but pretty much the day after that is probably gonna be sunny. You know, so you're pretty much gonna have a continuous of sunlight or wind. Okay, as a quick reminder, there are 4 non-renewables and there are 5 renewables. Tossing it out there. Now, the non-renewables, those are only a fixed amount, meaning we will run out. I do agree with that. It takes millions of years to make. I mean, we're running a little low on finding diamonds. So what did they do? There is man-made diamonds now. They know exactly how to make a diamond, which is pretty awesome, you know, because there's only so much materials that you're going to find out there and be able to dig in the ground, because some things take millions of years to produce. Another thing when it comes to non-renewable is that the majority of them produce quite a bit of pollution. Example, CO2. That's not the only one, that's just the main example. And so for your lab grade, the carbon capture from NASA is asking you, hey, research what carbon emission is from these non-renewables. Hey, have you ever thought about, why don't we ever try to take the carbon out of the atmosphere? How would we do that, and what purpose would we do that for or with? Now that you captured the carbon, where are you going to put it at? Or what could you use it with? So it's just kind of one of those, for those of us who are thinking about going into engineering or something like that, this lab, this thing that you're going to do is going to get your brain thinking on that, okay? Because deep down inside, we all live on this planet Earth, all right? So our non-renewables, in no particular order: nuclear, coal, oil, and natural gas. Okay. Now the renewable, again, they also are good and a little bad. They're not perfect. We call those alternative to these non-renewables. You probably hear alternative energy. Well, that's a renewable energy. I will agree, they themselves produce less to almost zero waste, as in like carbon dioxide emissions and stuff like that. Okay, but to make them and to maintain them, it's going to use a non-renewable resource. So they don't have, you probably heard that word, zero footprint or a carbon print. No, they don't have zero, because we still have to use this. And they can replenish by natural means in, relatively a short time frame. Now, to like grow your wheat and corn, it might take a year or two. Or wood, okay, it might take 5 to 10 years for that tree to grow to the full length. But that's still way shorter than millions of years. In no particular order: solar, wind, hydro, bio, and geothermal. Okay? Now, besides those 2 pages that you're going to go tonight or tomorrow before you have class, because you probably don't have 4 hours of class tomorrow, you can sit down with your laptop and you can go to D2L and you can fill in those 2 pages. But look, when I turn the page, I'm done with our middle school notes. Okay? So that means sometime next week on Tuesday, Thursday, or Friday, you're going to have a quote-unquote pop quiz over the 6th grade notes. Do not do less than a 90, right? Don't do less than that. It's embarrassing. Now, before you leave, I've got one more thing to go over with you, okay? Did I tell you that, my brain is forgetting. I already told you that the project